to the SEJ ecosphere. First off, we're going to have Hamlet Batista, CEO of RankSense. You can find him on Google at Hamlet Batista. Hamlet's going to be really digging into how to create a content strategy at scale, looking at things like AI implementations, data implementations, and he's going to have some great surprises of stuff that's on the Google and Bing side that I really had no idea existed until I ran through his presentation. So let's get started right now with Hamlet Batista, followed by Ayeda Solis.
Hello, this is Hamlet Batista from RankSense. Excited to be here and ready to share some really interesting insights. Doing more with less, automated high quality content generation, right? Really bold and really intriguing, right? Let's see if I can deliver on this promise. So if you don't know about me, I'm the founder of RankSense, and I tweet a lot at Hamlet Batista, and I have a column in Search Engine Journal that you can check as well. I write a lot about Python guides and how to automate SEO, tedious SEO tasks. And how many times have you asked this question, right? That you are writing a Gmail, start typing, and Google automatically completes the whole part, and it's super accurate, right? It's really fascinating, but at the same time, right, it can be really scary, right? And I want to challenge you and tell you that you might already be using this AI technology in your work without you even realizing it, right? So if you're using Google Docs, Smart Compose, or Gmail, or even in Word or in Outlook, you're already leveraging this technology because this is part of your day-to-day as an SEO to be when you're communicating with clients, right? And you might think that that technology is only accessible to Google, right? But that's not the case. I want to invite you to visit this website. It's called Transformers. You can see the URL here, Hugging Face. And in this, they have this nice tool, this Word doc as a proof of concept. I only took the title of my last article for SEJ, and I started hitting the tab autocomplete command, and everything was written by that machine. All of this was completely generated, by a computer without me having to type anything. And the coolest thing about this is that this is actually the technology, the code behind that makes this possible is actually freely available and accessible to anybody that wants to use it, right? So I'm trying to put together some of these building blocks so you can see where I'm going to. So another element that I wanted to introduce is this was a really interesting and popular article for SEJ. It was published recently by Mindy Weinstein, and I took a few quotes that I thought that stood out for me, right? And it's about what are the trends, what are the things that we're seeing the shift that is happening, right? And in the traditional way that we've been doing keyword research, right? There's the transition to intent-based searches, right? Instead of just pure volume, and the shift also to questions, to understanding what are the questions that our customers are asking to describe their problems. Essentially, we're going from keywords to questions, right? This is very powerful stuff. And what is the opportunity with all this I'm talking about? Right, is that when you're writing content, effective content, you're thinking about the search engines as answering engines. One effective way is to simply answer those questions from your users. Find those really interesting and popular questions and answering them. And if you look at it, when you do it right, in this case, this Python for SEO guide by JC, you can actually not only answer these questions, but also capture a lot of real estate in the search results, right? How cool is that, right? Really powerful stuff, right? And to leverage that, you can also take advantage of of the latest tools Google provides us in terms of rich results, which is the FAQ search snippets. But, obviously trying to research those questions and writing them, providing the answers is a lot of work, right? It's a lot of manual work, right? And that's what we're going to fix in this presentation. So you can expect from me. We're going to automate it using the latest AI advances and your existing content assets, right? So let me talk about a little bit more about that, right? What I mean with your existing content assets, right? Most businesses have proprietary knowledge bases that they have developed over time just by the normal interactions with customers, right? We're talking about support emails, chats, internal wikis, right? All this interaction in the way that you're serving customers, you develop those knowledge bases, right? This is an example from the Juice Pool game, right? And this is the cool thing that you can do with that, right? So you can leverage public algorithms and knowledge bases, right? And combine them with this proprietary information that you have, right? And if you look at the difference between traditional ML and deep learning, which I write often about, is that in traditional ML, you're primarily doing, classifications, you're leveraging existing knowledge to come up with the predictions. Now with deep learning, you're able to tap into common sense knowledge that has been built over time by big companies like Google, Facebook, Microsoft, DeepMind. Those are the public data sets. We're going to deep a little bit deeper into that. And the proprietary knowledge from your business, right? We can combine both to come up with new content. I'll walk you through what those look like, right? So what is the agenda with that context, right? We're gonna source popular questions using online tools. There is no need to write any code. It's the cool thing. So just by following these steps, you'll be able to produce new content. And we're gonna leverage 3 natural language generation approaches, right? Doing a search to find the answers once you already know what the content that has the answer for it, or one of the most fascinating advances that is just very recent, like a couple of months or so, that models can actually answer questions without you providing the context, without you saying, this is where the answer is. Can you give me where the answer is, right? And then, we can leverage the search feature by adding FAQ schema and testing it on the structured data testing tool, right? Okay, so let's get started. Right, so now how do we source some popular questions, right? There are a number of tools, and we're gonna just mention 3 of them that are, very popular to find questions that are popular by users. Answer the Public, Question Analyzer by BuzzSumo, and Also Ask, right? Answer the Public, you type a question, face masks, and a keyword, type a keyword that is popular right now, face masks, and you can get a lot of different questions that are popular. What are the best masks? Can face masks be reused? Can they make you sick? Do they expire? How do they help? How should we fit them? How do they work, right? So there's all these different questions that your users are asking. So basically, it's not very difficult to find popular questions. Another one is BuzzSumo. They aggregate information from forums, for a lot of different places, and you can find more long tail type of questions, right? That can be really interesting. It's the jar and washable at 60 degrees, needed for any face mask adapters, or you find a disposable mask, right? Should you wear them, right? So it's really, really interesting, right? This is another really interesting tool. It also asks that scrapes the people also ask questions from Google, and then can create all these different questions, right? What are the best masks? Do face masks help your skin? right? Why do surgeons wear Crocs? So it's really interesting, all these different questions, right? But they're real questions from users that they're asking, right? So essentially, finding popular questions based on your keywords is not a big challenge. All these tools, I use the free version to put this together. It's not a big problem, right? So now let's see about how do we start putting together the system that can answer those questions, right? One of my favorite places to find the code to do this type of leading edge research is called Papers with Code, right? Papers with Code allow you to tap into the absolutely latest state-of-the-art research that is being published for free by academics, researchers, that they post it so that they can get feedback, their papers from their peers, and they're always challenging each other to try to come up with a better system. It's fascinating to watch this. But more interesting is that we get access to the code that we can use ourselves. And that's the same case for answering questions. You can go to the section on answering questions, and I can, in the specific paper and code that we're going to use is T5, which is the model from Google. And in addition to, and I wanted to, that question and answer is a really broad topic there are subtopics within it. Part of them is the ones that we're going to cover, the open domain question and answering, and also the closed book, question and answering. But it's a lot of variations on that, right? So with that, we get the code that we're going to need to answer the questions, the system, but we also need the training data that the system is going to use to learn to answer questions. So one is the free algorithm, the other is the data set. The most popular one is from Stanford, which is the Stanford question and answering data set, version 2.0, right? That's the most popular one. And I want to show you in the leaderboard, they have a leaderboard, incredible it is that they have a baseline human performance. They provided the same questions to humans, and the latest model, the model at the top of that is top performing, has already beaten the humans. Look at that by a lot, right? 86 versus 90, 89 versus 93, right? How crazy that is, that machines are now at this task of answering questions superior to actual humans, that were tested against it. Incredible for me. It's really, really fascinating. So now that we have the data set and the code, let's talk about the first approach, right? Which is now how we get the system to answer the questions with 3 simple lines of code, right? Importing from the transformers library, importing the pipeline, allocating the pipeline set, the question and answering. This is something that you can type in Google Colab. Open a notebook. Colab is in Google Drive. Search for Colab, open a notebook, just type these comments, one after the other. And I type the comment where I provide the question, and I also provide the context that I believe has the answer to the question, right? And you can see the system basically perform a search for the string that has the answer, right? And the confidence that it has the answer, right? And it got it right. It's fascinating. This is very simple. It's something that you can get, right? And the steps: loading the library, the NLP library, allocating the pipeline, and providing the context, right? And how are we going to get the context? Another simple code, a few lines of code using the request HTML library. We can pull the URL, which is equivalent of navigating the browser to the URL and providing a selector. Selector is the path of the element of the block of text on the page that I manually got from SEJ from this article. And I should simply make a call to pull the content and add it to the text. And that becomes my context. So I said, I'm going to ask a question that is included in that article, right? That means that I know where the answer is. I'm providing the article that has the answer, right? But let's try something a little bit more ambitious. What if we don't know what article contains the answer that we're trying to ask, right? And this is the part that we're getting to the mind-blowing thing that is happening right now, right? Both Google and Microsoft released some amazing models that monster models. The Google T5 model has 11 billion parameters. The Microsoft model has 17 billion parameters, right? Both of these models are able to answer questions without you providing any context. So it's just based on what they learn. They're so massive that they're able to keep a memory of a lot of things when they were trained, right? Incredible, right? And this is the two ways that you can, answer the questions, as I mentioned, the open book, where you know where the answer is, right? That we tried already, and the closed book, that you don't even provide the, this is a concept from academia, right? That you don't even know, you're not allowed to search for the answer in the book, right? You're not able to cheat, right? But closed book and being able to answer that, incredible, right? And this is the part that I love the most. The Google T5 team went head to head. We're talking about the geniuses that build the algorithm themselves, the PhDs, the scientists that built it. They went head to head in a trivia contest with the model, right? And they lost. Think about that, they lost. So you want to try it yourself? Go to T5triviaglitch.me and see if you can do actually better than them. I was amazed to learn that, right? So now let's get to work. Let's see how simple it is to train T5 to answer our own arbitrary questions. Super simple, right? And we're gonna train the 3 billion parameter model in the free Google Colab notebook that anybody get access to using the TPU, right? And one question that I asked the model is, who is the best SEO in the world? So I'll challenge you right now, try to guess who that is and see if you get it right, right? If you try, but don't cheat and say that it's yourself. Sadly, I tell you that it wasn't me either. So let's see if you can guess who is the best SEO in the world from a model that was trained, from Google, right? And if you didn't guess it was SEO Moss, you got it wrong. You lost your money, right? I'm sure Moss will be happy to learn that. Okay. So here's the technical steps. We're gonna copy the notebook in Google Drive. You have the link in the deck here. Set up the environment correctly. Create a cloud storage to store the progress of the model training. And then we're gonna set up the bucket that we created in the notebook and select the $3 billion parameter model. Yeah, and that's it. Just run some of the steps. And this is what it looks like. Sounds more complicated than it is. So we save the copy in Drive. Change the runtime here. So it looks when you change it to the TPU runtime. It's a very intensive task. In Google Cloud Platform, you create a bucket to save the progress of the training, right? Then you specify that bucket here in the model, right? You can name it whatever you want, right? And then you have to run all the steps after you set that up, run the steps up to the defined model and select the 3 billion parameter model, right? And you're gonna complete all the steps up to the predict, right? In the predict steps, that's where we're gonna provide our own answers, right? And that's it, as simple as that. You got a model that can actually answer questions. And that was actually easier, very simple and very easy with this tutorial, right? But let's say that we now, as you saw, the model said, SEO models, the model is not gonna have answers to proprietary knowledge that you have. How do we add your proprietary knowledge so that it can answer questions in your domain, in your industry from your website, right? And that's where we go into the fine-tuning step. So you can click to the fine-tuning step in the model, right? And there's some examples in the code of how to create new functionality, how to give new capabilities to the model, right? It's a little bit out of the scope of this talk, but here's the steps, right? And I provide an article, the last article that I published for SEJ walks you through the step of generating your own data set, because here is, you have to prepare the data set in the format expected by the model, right? And adding FAQ schema. So here is straightforward. You go to the Google Docs documentation for the FAQ, add the JSON LD structure for that. If you want to do it automatically, I also wrote an article about it in SEJ of how to use it with JavaScript. With JavaScript, you should be able to generate this JSON LD. It's in this article, right? Some resources to learn more here about introductions to Python and machine learning, and a lot of the different elements that I presented today, right? And if you want a commercial solution for this, you want to check out MarketMuse First Draft. They have an amazing tool coming out to create the drafts with natural language generation. About our company, RankSense, we automate tedious tasks in Google Sheets, and you can import those sheets and deploy them as experiments in Cloudflare, and then learn which one of those experiments are effective so that you can deploy them across the site. And thank you.
All right, great stuff, Hamlet. Like I said, learn from you every single time we either talk or read one of your posts. Okay, now the next presentation is going to be by a